Okay, so to start this homework off, we have question 47. Um, Before I even go through this problem, I think it's really funny to just mention how this problem is about spreading rumors. I don't know. I feel like that's an every school thing, but it's really funny about Abby students spreading rumors. Anyways, this is kind of this top part right here, just unnecessary. The only important thing I think of note is I'll underline is that there's I'm an eraser. Is that there are 1,000 students. Um, but I think out of all of this, I don't really think it matters. Um, so we have this equation, which is a series, which basically says after how many hours, um, how many students know the rumor, in relation to how many people knew this rumor the hour before, if that makes sense. And it's given to you that on the 0th hour, here I'll underline this, 3 students know the rumor, which is a complete lie, but whatever, we can do this. And it's the first part is to calculate S1, S2, and S3. So I'm just going to rewrite the equation. And instead of including the multiplication, I just put it next to it. I think that's just customary for me. But you could keep the multiplication. I'm gonna simplify this. So the first step I'm gonna do is I'm gonna multiply these two. So this, because this is in parentheses, you have to distribute the s to the n minus 1. So this would be 1,000 s to the n minus 1 minus, and then this is s to the n minus 1 squared, because they're squaring, and then they're both over 1,000. Here it's really nice. We can see that 1,000 and 1,000 cancel out, so I'm just gonna cross that, and then s to sub n minus 1 and this one are like terms, so we can just add them together. So then we get s to the n equals 2 s to the n minus 1 minus s to the n minus 1 squared over 1,000. I can see that 2 is in a very bad spot, but whatever, I'll keep it there. Hopefully you understand how I just rewrote this equation and just moved it down here. And this is the most simplified form. So here it's asking you to find 1, 2, and 3. And knowing, I'm going over here, knowing that S0 is 3. So S1 would be equal to 2 times 3 minus 3 squared over 1,000. And I'll put this in parentheses to input what I shown. And this would equal, I think it's 5.991. I used a calculator beforehand when I solved this problem individually. It should be 5.991, which obviously you can't have fractions of a student. So I'm just going to assume that 6 people understand the rumor. So that's for one student. Now let's do this for 2. Now I am going to use this, the whole number. I think it would just be easier, because we also have to solve for part B, something that will be nice to use whole numbers for. We will input the number, so 2 times 6 minus 6 squared over 1,000. And if I open up my Desmos real quick, I already did these calculations. It equals 11.964, which again rounds 12. And then let's keep going. So for s sub 3, you would do 2 times it, and I input this number right here. So 12 minus 12 squared over 1,000. And this equals Desmos 23.856, which of course rounds to 24. So that's the answer for the first 3 parts of the problem. The second part of the problem then asks, basically suggests that if you add up I don't know why it's formatted like this, but it's basically stating here that 2 times s sub n minus 1 equals s sub n. So it's 100% growth, so multiplied by 2, and explain why the model becomes less realistic. There's a reason why I did it this way. As you can see in this equation, and I will highlight it with my red thing. This equation already has this 2s sub n minus 1 in it, and then this here is sn minus 1 squared over 1,000. And the reason why it's saying that, and if you can see here that it looks like it works, right? 6 times 2 is 12, 12 times 2 is 24, is because the number, right, like 3 squared over 1,000, that's 9 over 1,000, is so negligible to the number, or like 36 over 1,000 is so negligible that you would round up, right? Because you can't have portions of people knowing. But what happens is when the number gets bigger and bigger, obviously this number will get bigger and bigger and will actually outweigh this number right here. But while this number is small, it doesn't really affect this ratio right here, which is what the question is asking. So I think this question, while very long, is pretty simple to understand. So I hope that that makes sense, and we'll move on to the next problem. Okay, so moving on to question 48. It's a continuation off of problem 47. Right off the bat, this p function right here is useless for the first part of the problem, and for the second and the fourth part of the problem. But the second, b and c, when it tells you to graph it, I'm not going to include that part in this explanation because I trust that you know how to graph points using by plugging in numbers, and I hope I don't have to explain that. And then you can also, and for C, you can look at the graph and you can make your own judgment. But for A and B, for A, it's asking you to find out the percentage of the student body who knows the rumor by 5 p.m. And then they also want to know by 10, it says 10 o'clock, which I'm going to put a question mark. I'm guessing that's, and I'm gonna, make an educated guess and say that's 10 p.m. And then what percentage know by 10 o'clock? Now I'm gonna throw a little curveball. So I'm not gonna write the p function. I'm actually gonna make my own function. This function I'm just gonna call, let's say, d of n. And this d of n is gonna be very similar to s of n. So I'm gonna actually write below this the s of n formula, which equals n 2n of s minus 1 minus s of n minus 1 squared over 1,000. I'm actually going to move this a little down. Yeah, let's do that. I hate that's there, but we'll move on. Here, also knowing that s of 0 starts at 3. So here, I'm going to write 3, which is my base point. And then since it's multiplied by 2, this is just, I don't know if you would consider this compound interest, but it would have the same relation. So we would do 3 times 2 to the n. And to fact check this, right, we have 3, s is 0. So if s is, and n is 1, that should be 3 times 2, which is 6, and here it's 3 times 2, which is 6. If at n is 2, we know n is we know s n minus 1 is 3 because of what we just solved. No, not 3. Sorry, 6. So 6 times 2 is 12, And here 2 to the 2 is 4 times 3 is 12. So this right here is just equivalent to this part of the equation. I don't know if you can see the highlighter right here. And then for this part, I'm going to keep with this notation. Minus s sub n minus 1 squared. That's just 3 times 2 to the n minus 1 squared. And I put that all over 1,000. And now again, the same explanation. I'm just making this equation in terms of an exponential, and you'll see why in a second. So that means that you have I just did the same exact thing here. So like if you would plug 3 like s as 1, s is 1, that would be 3 squared, right? And if s was 1 here, would be 2 to the 0, which is 1, which is 3 squared, it's 9, right? And that's 9 as well. 3, yeah. I hope that makes sense. I know I was speaking really fast, and I'm assuming that you understand how I converted from here to here. But I really what I just did was this function here increases by 2 times, so that means that it will always be exponentials of 2, if that makes sense, because it will always multiply by 2 because of this area over here. Now, what does that mean? Why did we create this d sub n over here? Now, the reason why we did that is because for this question, it's asking by 5 p.m. So for d of 5, it equals 3 times 2, and then here we're lucky, right? We use this function, 2 to the 5 minus 3 times 2, and again it's 5 minus 1 right here, which is 4, over 1,000. I'm just gonna say it right now. I think we can ignore this number unless this number is greater than 0.5, because then we would round it. So that's 2 to the 4, which should be 4 to the 2, so that's 16. 16 times 3 is 48. 48 squared is like 50 squared, which is like 2,500. Yeah, 25. I probably just butchered the math. I could just go on a calculator right now and do it. So right now it's saying it has actual a big number. I'm pretty sure it's like around 2.5, this number, so we actually got to keep this into account of the equation. So I'm just gonna keep that in and go on Desmos or whatever calculator you have, do the math, and for me it says 93.7, which is, I'm just gonna say is 90, which I'm just gonna say is 94 students. Okay, now it's asking for 10. So with 10 hours, it's going to be 3 times 2 to the 10 minus, again, we're going to do this, 3 times 2, and again to the 9, because it's a minus 1, squared, over 1,000. And I'm pretty sure if this value matters, then this value would matter. So I'm just going to keep this in. Again, you should have the same equation on Desmos already put in. I'm just going to put it in real quick. I get 712.7. I'm going to round this up to 713 because you can't have a percentage of a student. And then 713 students over 1,000. I'm just going to cancel the 0 and put a decimal point here. And that's 71.3 over 100. And this should equal 71.3% of students after 10 hours knows the ruler. So hopefully that made sense with this d of n function I created. But yeah, otherwise, that should be right. So moving on to the next one. Okay, this question is going to be a very short one. You're looking at the figure at the right and you're making an interpretation about the geometric series. I would heavily recommend to do this problem by yourself, to come up with your own idea of what this figure right here means in the sense of a geometric series. However, I will show my idea. So obviously you can see that this is like a spiral and it's in the shape of a rectangle. So what does that mean? Well, that means that probably as this gets, closer, so if we have the sum from 0 to infinity, this is 2, and it's 2 to the n, so it's 1 over 2 to the n. And if you don't understand sigma notation, I explained this in the previous homework problems a little bit. But you're just, it's like if anybody's familiar with coding, it's just like a while. It's like a while loop. So it would be this. The first term would be at 0, so that would be 1 over 2 to the 0, and then it goes up by 1, so that would be 1 over 2 to the 1, and it will keep going until this number reaches this number, which obviously would never happen, but that's what we're dealing with an infinite geometric series. Basically, what this is trying to tell you is it becomes a square, or at least this one, it looks like it's gonna be a square. So I think that's I feel like that's kind of interesting. I don't know what to add on to that. But yeah, I think that's what's kind of cool. Yeah, and I'm pretty sure this sums up to because this is 1/2. The area is 1/2. So I'm pretty sure this is 1 and 1, and I'm pretty sure the sequence of this is 1. And we can prove this by the a over 1 minus r to the n over minus r. But I'm not going to go into this. That's just writing down what I'm thinking. So anyways, on to the next problem. This problem was pretty trivial. All right, on to question 50. Now this question's also pretty easy. I feel like they felt bad with 48 and 47 and 48, and they're like, okay, 49 and 50 are little breathers. But so here it says consider the function f defined by f of x equals the absolute it's technically the absolute value of sine of x, but I'm pretty sure there's another name for it that I'm just forgetting. Anyways, it doesn't matter at all. Let's just draw this graph. So a normal sinusoidal wave will look something like this. I apologize for my terrible drawing skills. Yeah, I'm just not gonna accept that. But it has to intersect this, like something like that. You know what I mean? But for the absolute value, every place that it's negative, it's positive instead. So this would just go up. So it would look like a happy little jump, like leapfrog. And that's because all the parts that you see are negative just get flipped. So this becomes this becomes this. I think this is pretty trivial. So this is the graph. I mean, all you need to do is just draw the sine of x graph, and then any part where it's negative, you just flip it to the positive axis to where you get the absolute value of x. And then the second part of the problem is explain why it's not sinusoidal. I looked up the definition of sinusoidal, and it said the first definition is having the form of a sine curve. So with that definition, it obviously does not look like a sine curve. I think that's it. But another one is saying that it's smooth, and I won't really get into what smooth means, but you see how there's like a big like jump, like an indent there. I think that's what it means by it not being smooth. That's what I'm assuming that's what this definition means. But anyways, just stick with the sine curve idea. This problem was pretty easy, so it'll be a pretty short video today. But yeah, maybe I'm gonna